Okay, hello everyone. This is another lesson, okay, on chemistry, and today I am going to start the lesson with a new topic, okay, and this new topic is called redox. All right. So before I begin, okay, you would like to start off with a new A3 paper. All right. With that said, a new A3 paper would be planned out in a certain format, okay, and this is my format recommended to all of you, as you can see on my screen over here. All right, okay, you would like to have sufficient spaces on your left side, okay, for you to scribble your notes, okay, for the following headings, okay, as well as an entire full column on the right side here. All right, okay, and this is actually for you to write out the notes as well, okay, for another segment of this chapter. Okay, without further ado, okay, once you're done, okay, let's proceed with the chapter Redox and the introduction. You may wish to pause this video at this point, okay, just to make sure that you get everything out first, okay, before you proceed, because I won't actually slow down in my talking. So let's get on to it. All right, okay. So redox is a very interesting chapter. Redox usually comes in right after you have learned adequately enough chapters or in the chemistry chapter. So in the chemistry subject itself, so for, say for example, you have already learned by now displacement reaction, acid reactions, um, metal reactions. Even the most recently would be reactions pertaining to reactivity series of metal. All right, okay, and so on and so forth. So redox is a summation, okay, of all these reactions you've learned so far. But interestingly, why would I put redox with a particular logo of an ox? And maybe even so, why does it spell so weird? Okay, with the word RED and OX. Right. You have it guessed right. Okay, redox is basically okay two reaction together. Okay, one being oxidation and the other being reduction. Now, a redox reaction, okay, is one where these two reaction, oxidation, okay, together with reduction, okay, occurring, okay, at the same time. All right, now, so uh, we can use this term, okay, if you're familiar with this, which is simultaneously. All right, okay, and that is basically the overview of the idea of redox. Now, however, okay, because of this definition redox, we introduced two smaller terms, okay, which is oxidation, then reduction. Now, these two are reactions that is often discussed in this chapter itself, and we're going to look at them, okay, with respect to this, okay, more clearly, okay, to understand how okay we can observe oxidation or a reduction in a certain cell reaction. Now, in most cases, let me repeat that again. In most cases, most of the reaction actually has oxidation and reduction occurring simultaneously. And yes, I have not yet touched on why is it called redox yet. So the word redox, okay, which is RED, okay, coming from the word reduction. Okay, this word is actually reduction. Okay, and the word OX, okay, comes from the word oxidation. So hence, the word redox is actually uh, mentioned like in this way. Now, I'm not quite sure if this is actually intentional, but I guess it's easier for us to remember. Now, okay, so oxidation and reduction are common thing. There are a lot of common things in our daily life, and as well as reactions that you're already exposed to that actually has oxidation and reduction occurring at the same time. Now, say for instance, let me introduce you some example. Like for example, what you see on the screen now, okay, is an example of rusting. Rusting is an example of oxidation, okay, where iron actually oxidizes, okay, by combining itself with the oxygen molecules in the air to form a rust, okay, which is iron oxide. We can also find redox reaction in displacement reaction. I think most of you will find this particular diagram pretty familiar, okay, because of the fact that zinc, okay, is a more reactive metal, will displace uh, copper, okay, the less reactive metal, and as a result, you tend to see the formation of copper, okay, on the surface of zinc, okay, and that the solution also gets paler in blue, okay, as copper is being displaced out of the solution. We also see redox in fact in common daily examples like for example apples. Apples turns brown is an example of oxidation. Alright, okay, so that I think is very relatable. Last year we learned about displacement of halogen. Okay, in this case displacement of halogen we talk about a more reactive halogen displacing a less reactive halogen out of its salt solution. So just maybe a quick uh, share okay with you the purple on the leftmost, okay, as you can see here, all right, okay, is actually the iodine. Let me just do a bit of edit, so a bit of editing and labeling so you can find this relatable. This one over here is actually the color of the halogen iodine, okay. This color right over here reddish brown is actually bromine. All right, okay, and the last one in this list here, this will be chlorine. Now they are basically being displaced out from the salt solution, okay, via displacement reaction, and that's it. Displacement reaction like this, okay, is also a redox reaction. Well, what else do we have? Okay, we have another one just to show you as an example. Our most recent example where we saw reactivity series of metals reaction with steam. Okay, is yet another example of a displacement reaction. In this case, all right. Okay, just again to give you a quick overview of this reaction. How is it related to redox? Okay, I deploy okay the an equation, okay, to explain this. So if you still remember, okay, let's make this a little bit bigger. If you still remember, magnesium reacts with steam, all right, okay, that gives you magnesium oxide, okay, and hydrogen gas. Now, here, okay, there is a redox reaction occur, okay, between the reaction of magnesium and steam, okay, which is H2O in this case. All right, okay, and we will find out more as we slowly move into the chapter, okay, to learn more about how this equation help us to see the presence of oxidation and reduction occurring uh, itself in the reaction itself. Okay, so let's get back to our slide here. So redox can be remember over four things. Okay, there are reactions. Okay, we observe reactions with oxygen. Okay, all right. We observe reactions with hydrogen. All right. Okay, reactions with uh, electrons, okay, and reactions that concerns oxidation state. Now, oxidation state is something new, okay, which we'll spend more time exploring the meaning behind oxidation state and how do we get to understand it better. Now, all in all, sometimes being asked, we need to know how to differentiate oxidation and reduction. Okay, so we are going to do zoom in, okay, to in fact this one, right? Okay, right over here, okay, our first box over here. We want to understand what is oxidation in terms of oxygen. So in terms of oxygen, okay, this is what oxidation is. All right, okay, so oxidation, okay, is basically a reaction. Okay, oxidation is actually a reaction involving in the gain of oxygen. All right, okay, so that is very much understood as oxidation. Okay, so when the substance is oxidized, all right, okay, so in this case, it actually undergoes oxidation. Okay, all right. Now let's move on to what is reduction. Now reduction is very much the opposite of this definition. Okay, in this case, it is a reaction, okay, which actually involve in the loss of oxygen. Okay, so you can see that oxidation and reduction are kind of the same but just opposite to one another. Now with that said, Alright, okay, let me just share some examples, very common examples with you, okay, so that you can easily see oxidation and reduction occurring, okay, in reactions such as this. So our very first example, okay, would be something where metal, okay, will react to oxygen. So here I would like to relate one of the example, okay, of oxidation. Say, for instance, when you burn, okay, magnesium. Now I'm doing a little bit of padding in. Okay, when we burn magnesium, okay, in air. So what really happens when we burn magnesium in air? Now this is a reaction that occurs. Magnesium reacts with oxygen in the air, alright, okay, to give you magnesium oxide. Now I can do a quick balance equation, okay, and to do so, okay, you see that the number 2 comes in front, okay, to show that the equation requires this amount of atoms on the left side and on the right side, and hence the equation is balanced. Now, from this equation, okay, one can see that the oxygen, okay, itself, okay, involving in the reaction, ends up becoming part of a compound, okay, made between the reactions of magnesium and oxygen. Now, with that said, okay, we can see that magnesium is no longer just magnesium, but in fact, magnesium has gained oxygen. So for this, okay, we can actually write something like this to explain our explanation, and that is we can say that magnesium, all right, okay, is oxidized. Now, don't mind me, you can actually use chemical formula mixing together with your sentences, but that's okay, okay, as long as the formula that you use are correct. So instead of spelling the entire word magnesium, I can actually write Mg, okay, keep in mind that M is actually a capital M, okay, so Mg is oxidized. Now, then followed by an explanation to what I see here. So I will say that Mg, okay, gain, okay, oxygen, right, to form MgO. Now, there is a certain format you're actually writing this, just in case you didn't see this. Now, the format goes like this. First, you always start by reporting what is being oxidized. Then, you report, okay, what justify the term oxidation, which is gain oxygen. And then, okay, you quote something what is before and after information. Now, let me show you where's the before. Before, all right, and after information. Okay, one more time. All right, okay, just in case you didn't catch me, all right, you need to combine the evidence of gain oxygen using before and after statement. So this is a before, all right, and this is an after. All right, so where is this before and after, if you might wonder? Okay, the before and after is actually here, right? This is what happened before, all right, okay, and this is what happens after. All right. Yeah. All right. So when you write answer, please remember, okay, to keep this particular format. Okay, so it will help you, okay, to write really good answers, okay, when explaining the term oxidation itself. Okay. Sorry, I just need to do a bit of a add up. Okay. All right. So there you go. Okay, so with that said, let me just give you another example, okay, of the term reduction. Okay, so we have done with oxidation, so let's go to reduction. So for reduction, okay, we are also looking for something that discuss about the loss of oxygen. Now, with that said, I think now, okay, easier, okay, would be a reaction which goes by something like this, a more complicated reaction. So say, for example, I have a reaction that involves in the displacement, okay, of uh, copper, okay, from copper oxide using, okay, zinc. All right. Now, the equation will look something very much like this. So if I were to heat zinc, all right, okay, together with copper, okay, all right, okay, at very high temperature, what happens is that the zinc, being more reactive than copper in the reactivity series, I'll add a side note to this, all right, zinc is actually more reactive than copper. The greater than sign explains this phenomenon. All right, okay. So what I will get, okay, is that zinc will take over and becomes oxidized. Okay, he will bond with the oxygen. Okay, and then leaving copper. Okay, being displaced out. Okay, now for such an equation, right? I want you to spot where is the reduction based on your concept, okay, of oxidation and reduction. All right. The definition above, okay, will say that reduction is involving in the loss of oxygen. So which of these elements do you notice that there's actually a loss of oxygen? Okay. Please pause the video, okay, so that you can spend a bit of time thinking, and do continue to play the video, okay, when you already had an answer in mind. All right, that's it. Okay, without further ado, here we go. Okay, so for this case, okay, reduction, all right, okay, it's very much observed, okay, over at copper. Now, however, please do not let your eyes stray. Okay, I will always recommend something somewhat like a common practice that goes in this particular order. Now, I would okay start by looking at the left side, okay, usually, right, to look for any element, okay, to begin with, and I ask myself what happens after it has reacted. So after it has reacted, you notice that copper then kind of becomes nothing but itself as a metal. So with that said, okay, that is quite clear, okay, or it is quite clear that I can witness and see that actually copper loses its oxygen, okay, as a reaction, as a result of the reaction with zinc. So I found my answer, okay, now I'm going to craft this, okay, and so I'll write something like this. Now, I will always start by mentioning which element did I see that it undergoes, okay, a particular reaction. So in this case, this substance is actually the reactant, so I'll report first the reactant. All right, so CuO is the reactant, okay, is actually being reduced. All right, okay, so what evidence do I see from here? CuO is reduced, and in here, what we saw is that CuO loses oxygen, okay, to form Cu. All right, now there you go, a complete answer. Now, one reminder again, okay, how is this forming answer begins, or rather how the craft this answer. I always start, okay, so the format of the answer, okay, always start with first, okay, the reactant, okay, whether would it be reduced, okay, or oxidized, okay, then semicolon, followed by an explanation to what happens to the reactant, okay, whether it has actually gained or lose oxygen, all right, to form, okay, the corresponding product, which is on the right side of the equation. Now, this is a very strongly recommended format, okay, in writing an answer. This is almost ideal, all right, and you should remember and learn this format because it will really help you a lot in writing very good, consistent answer, okay, when you are supposed to explain oxidation and reduction. Now, I will throw in another example, or just one last example, okay, to show gain loss of oxygen. Okay, this time round, I would like you to look at this equation, okay, the third example, and see whether if you can spot both oxidation and reduction. All right, okay, now this reaction is actually one of the photo we saw just now, one of the example we saw just now, where we actually burn, all right, okay, all right, or the reactions of magnesium, all right, okay, in steam or with steam. Okay, all right. Now, so I'm going to write down the equation and let's see if you can spot it. Huh? Okay, so magnesium reacts with steam. Okay, steam is actually water. Okay, it gives you magnesium oxide. Okay, and hydrogen gas. Now, I will pause for a second again for you to ponder. Okay, can you spot a reactant that undergoes oxidation? And likewise, can you also spot a reactant that undergoes reduction? All right, okay, you will pause this video, okay, because very soon in a couple of seconds, I'm going to start talking again. All right. All right, so continuing from here, all right, let's see if we can identify a reactant that actually undergoes oxidation and another reactant that undergoes reduction. So we will do our left and right check, okay, and that will be one of the techniques we can use. We're going to use a green color to look for the substance that undergo oxidation, okay, so or reduction. So let's just start with the left side. So we look at the first reactant on the left side, magnesium. This is magnesium before, alright, okay, as Mg. This is magnesium, okay, after the reaction as MgO. Now you have noticed that magnesium, okay, from Mg to MgO simply implies that it has actually gained an oxygen. So which also means to say that magnesium, okay, as a reactant, has actually undergo or rather is oxidized as a result of this reaction. So hence said, alright, okay, let's write this down in green. So I would say write something like this: magnesium. All right. Sorry. One more time. Magnesium. Okay. We write the name of the reactant is oxidize. All right. Okay. Then followed by explaining that magnesium, okay, gains oxygen. Okay. Actually, it's just an oxygen. Okay. To form, okay, the product which is on the other side, MgO. Alright, okay, so on the same note, okay, we can also easily identify the substance that's actually reduced. In this case, oxygen, again, check from left side to the right side, oxygen, sorry, water, steam, okay, on the left side, H2O, okay, and uh, hydrogen, okay, on the right side that was formed. You notice that from H2O to H2, alright, okay, is an evidence, okay, of a reduction as the oxygen is actually lost, okay, from the formula itself. So hence, with that said, okay, let's write down, okay, the statement, okay, of what I've identified, okay, the substance is reduced. In this case, my reactant H2O, okay, is reduced. Okay, and to prove this with a statement saying that okay, H2O, okay, loses oxygen, right, to form H2. Right, okay, so I hope through these three example, okay, has been very clear, okay, how you can arrive, okay, at an answer with an explanation to this answer. Right, so that will basically sum up, okay, the idea of oxidation and reduction in terms of uh, gain loss of oxygen. One more time, okay, just a quick summary is that if it's oxidation, oops, sorry, if it's an oxidation, okay, we will expect the reactant to gain oxygen, and if it's a reduction, then we expect the reactant to lose oxygen. All right, so keep that in mind. Okay, next up, okay, will be another area where we distinguish oxidation and reduction using hydrogen. All right, so with this said, all right, let's take a look at examples that will justify this case. Now, in this itself, okay, we'll look at some very common examples, all right, okay, which will involve in reduction and oxidation of the reactant, okay, in terms of the gain and loss of hydrogen. All right, okay, so first thing first, we want to just clarify a little bit, okay, that the idea of oxidation in this case, in terms of hydrogen, oxidation is, okay, a reaction. Oops, sorry, insert the word Okay, so as you have seen, okay, oxidation is a reaction involving in the loss of hydrogen. Okay, that said, okay, the opposite apply, reduction, okay, all right, okay, is the exact opposite. Okay, and that is the definition for reduction. Okay, basically a reaction involving the gain of hydrogen. Now, okay, we'll look more at some examples that will illustrate this. We start with maybe the first example, okay, very easily relatable. Okay, the formation of a substance called hydrogen chloride. Okay, now hydrogen chloride can be formed via the reaction between hydrogen and chlorine gas. Now that said, okay, hydrogen chloride is formed. Balance equation will look something like this. Okay, so over here, okay, you can easily see, okay, if you use the left and right check, you can easily and quickly, almost immediately identify that chlorine, okay, before it's just Cl2, but after, okay, it actually has a hydrogen in its formula. So with that said, okay, I have concluded, okay, that chlorine actually undergoes a reaction which involves in the gain of hydrogen. So that will be reduction. So again, the format of the answer will be starting with the statement, the reactant, okay, as identified, Cl2, okay, is actually reduced, all right, then followed by an explanation saying that, okay, what happens is that CO2, okay, gains hydrogen, okay, to form, all right, okay, HCl, full stop. Now, there is actually an opportunity for me to clarify one thing. Now, you would notice, okay, that in my answer, okay, over here and such, okay, I tend to leave the balance equation here. Okay, let me just highlight this out. Okay, the number two out of my answer over here. Now, you don't actually see me writing the balance equation number two, okay, which is in the equation, okay, not appearing in my final answer. Now, this is actually okay and very much acceptable because when we are explaining, we focuses on the substance itself rather than the number of reactants that was required to be used of as seen in the equation. So we don't actually need to quote the number that was actually used for balancing equation. Alright, okay, so with that said, okay, let's go to a slightly more complicated example. Okay, so we got to see a mixture of substances reacts together, and we can actually see both oxidation and reduction happening at the same time. So in this example here, okay, I will share with you an equation that looks something like this. Okay, this is hydrogen sulfide. Okay, reacts with chlorine. Okay, again, same thing. Okay, you get something like 2HCl. All right, okay, plus S. All right, okay, so let's just quickly look through, okay, this equation and see if we could identify which substance is actually oxidized, which of the reactant is actually oxidized. Now you may pause this video, okay, and give yourself about 10 seconds to figure this equation out, okay, and after, all right, continue the video to see if you have figured out it correctly. All right, okay, so with this said, okay, let us get on to it. Okay, oxidation is basically the loss of hydrogen. So we're going to look at a reactant that actually shows that it has actually lose hydrogen. All right, so if this is the case, okay, let's just check from the left side to the right side. I'm going to begin with H2S. This is H2S on the left side. Now what happens is on the right side, okay, the S for sulfur is actually seen, as a standalone. Alright, seems missing was, right, that this equation basically from the left side to right side check, you notice that there is actually a loss of hydrogen. Now the hydrogen is no longer part of the formula anymore. Well, that's it. Okay, you have just found yourself the reactant that actually undergoes oxidation. So how do we pick up from here? We can say that H2S, okay, is actually oxidized. Okay, and my supporting statement is that basically H2S, okay, loses hydrogen, okay, right, to form, okay, sulfur, which is S. And there you go, easy peasy. Now you start to get the hang of it in writing statements like this, and that's how it should have been, okay, up to uh, uh, this part of the explanation. Now we're going to look at just one last example, okay, to kind of wrap up things. Okay, we're going to look at an equation that looks slightly more complicated and see if you could manage this well as well. Okay, so on our third example, okay, we're going to look at an example that concerns a reaction between ammonia, okay, NH3, with copper 2 oxide, okay, and such reaction interestingly produces substances as follow. Alright, I'll balance the equation for you, okay, so it will be a no hassle for understanding. Alright, okay, at this point in time, you may also pause this video. Okay, we are looking for both, okay, a reactant that undergoes oxidation, and two, a reactant that actually undergoes reduction. Right, okay, pause the video and give yourself some thoughts over the next 10 seconds, and I will share with you the answer in a while. Okay, all right, let's move on. Okay, I'm going to use a red color, okay, to indicate the substance that has actually been oxidized. We're going to do a bit of a scan, all right, okay, to see what is going on. So I'm going to use yellow, okay, to identify the substance that actually undergoes oxidation. So start with the leftmost reactant, okay, focusing on NH3, not the balance equation, okay, and checking for something similar, okay, on the right side. Now, notice that what I saw on the right side is that NH3 nitrogen basically comes with three hydrogen bonded to form the formula NH3. But on the right side, okay, nitrogen seems to lose all his nitrogen, okay, leaving it, on its own as a nitrogen element, N2, okay. So, yes, you found it. The loss of hydrogen, okay, simply implies, okay, that this is oxidation. So, there you go. I will write down my statement. Okay, take note, I do not write the balance equation in. I'll just simply focus on the formula of the reactant. So NH3 is oxidized. Okay, then back this with an explanation is that NH3, okay, loses hydrogen. Okay, that's what we can see from this. Okay, to form, okay, N2. All right, there you go. Okay, very straightforward, very easy. Okay, remember, do not write, okay, any of this balance equation in, okay, or not. If not, okay, your risk, okay, at losing your marks. Okay, right. So let's move on to a reduction, okay, from the same statement. Now, here's the reason why sometimes reaction like this are called redox, because as long as you can identify one of the reactant that undergoes oxidation, you will also identify or easily, okay, the other reactant that actually undergoes reduction. All right, so with that said, okay, I'll still do the formality. I'll check, okay, my left side CuO, okay, and left side is CuO, and my right side becomes Cu. All right, okay. Now, a bit more to that, okay, because we are focusing on the gain loss of hydrogen. I would like to divert this attention to over here, all right, okay, which is H2O. Now, there is actually some interesting thing to point out. Okay, we'll just point out the most or more obvious one. Okay, the more obvious thing to point out here is that you will notice that, okay, see the oxygen before and after is that oxygen before was actually combined with copper, all right, okay, but oxygen after, okay, becomes combined with an hydrogen. That simply implies, all right, okay, that you can see, okay, quite clearly that CO, okay, is actually reduced. Okay, and my evidence here would say that CuO, okay, basically gains hydrogen, all right, okay, to form, okay, H2O. Now, this is okay, all right, okay, very much what we saw, okay, the gain hydrogen is obvious, okay, from a CuO becoming a H2O. Alternatively, okay, you can also have another answer, okay, right, let me just zoom in this a little bit, okay, something that goes like this. You can say that CO is reduced, then you go about saying that the oxygen, okay, gains hydrogen to form H2O. Now that sounds a little bit complicated, so usually I will not, encourage that form of answer. Now, what I meant by interesting earlier, okay, was that actually, if you could pay good attention close enough, you notice there's another evidence, okay, but not using the idea of gain loss of hydrogen, but rather the idea of gain loss of oxygen. So I'm going to mark this out, okay, a little bit different, all right, okay, so that you can view it with a dotted line, so it should be quite obvious to you, okay, that this is actually the case. Now this dotted line that you see here that points from CuO to Cu, okay. Now if you have guessed, okay, and you are right, okay, you will notice that, okay, what happens here you saw, okay, was that the copper, okay, okay, also shows evidence that it is actually reduced, but in a different context. Here you see that CuO actually becomes a Cu. Now, from a Cu to become a Cu, okay, it means that CuO actually loses, okay, is oxygen, okay, to form Cu. Well, that itself is also reduction because earlier, alright, okay, right over here, we saw that reduction is actually a reaction involving in the loss of oxygen. And over here, it proves so that copper loses oxygen to form Cu. And with that said, okay, now that will be also another possible answer you can apply. If the question is never too strict about your explanation to be in terms of anything, then you can write as freely based on what you see. But however, if the question requires you to be very specific, you have to talk about gain loss of hydrogen with respect to oxidation reduction. Then the first answer, all right, okay, which is over here, okay, will then applies. All right, okay, so with that said, all right, okay, this will be part of my lesson today, okay, sharing with you how to identify substances that undergoes oxidation and reduction, okay, in terms of the gain and loss of hydrogen. I would like to again reiterate, okay, what we have learned from this part, this segment, okay, is that when something is, when a substance undergo oxidation or is oxidized, right, it actually shows in the equation that the substance actually has a loss of hydrogen. Okay, on this note, okay, when a substance is actually being reduced, all right, okay, you can see that from the equation itself, the substance actually gains hydrogen. All right, okay, now our next segment will be me demonstrating to you how you could use the assignment uploaded, okay, to craft your answer. And I'm going to demonstrate to you how you arrive at the answer using the worksheet that will be assigned to you. Okay, so with that said, okay, let's move on to our next segment, okay, about completing assignment based on what you have learned today. Okay, hello everyone. What you see in front of me is actually the screen for your work that you're being assigned to. Alright, thinking maybe it would be better if I could demonstrate to you how this could be done, right? So that everyone can get their assignment completed. Alright, so with that said, okay, let's start. Okay, with this demonstration. Okay, now I'm going to show you how I could key in the answer in the respective boxes and what do they actually want, okay, from the given equation. Okay, starting from the leftmost, okay, you will see a reaction, okay, represented in the form of an equation. All right, okay, I'm going to use this, okay, as an example here, zinc and iron oxide. Okay, as an example here to show how this could be done. Okay, so from an equation, okay, you're going to use the skills that was actually being taught just now earlier. Alright, okay, you're going to inspect the equation. Okay, maybe, you know what, just let me make this a little bit bigger so you could have a better focus on what I'm talking about. Okay, so over here, alright, okay, let's analyze the equation. We're going to look for things that has been oxidized. You also are interested in the things that is reduced. Now, so with that said, okay, I'll start with zinc first, and let's see which one will it be, oxidized or reduced. Now, zinc as a reactant, okay, was Zn, okay, but after that, zinc becomes a ZnO. Okay, now from Zn to a ZnO simply implies that zinc has gained an oxygen. Now, gaining oxygen is actually oxidation. Okay, so well, I found it. Okay, so here in my answer, I'll write something like this. Okay, wow, okay, right. Zinc is oxidized. Don't mind about what just happened. Okay, right. Zinc is oxidized. Okay, so I will point that out, and I'll provide with a reason why zinc is actually considered oxidized. So that will be just similar to what you learned from my lesson about writing an evidence to support this. Okay, so that said, okay, zinc is oxidized, and we'll say Z zinc, okay, gains, okay, oxygen, right, to form zinc oxide. And there you go, we're done. Okay, reason supplied. Okay, all right, so next, which substance is reduced? Now, fortunately, because this is a redox reaction, so if one of the reactant is actually being oxidized, then the other reactant will be considered as reduced. So we don't have to look too
far or think too hard, okay, we actually found our substance that is actually reduced. So the reactant that is actually reduced is FeO. Okay, actually this guy is actually known as iron 2 oxide. Okay, so I'll just write this down. He's reduced. And my reason to why FeO is reduced is simply the same. Now observe what happens to FeO. Before FeO, after Fe. Yes, you had it right. It loses oxygen. So I'll write something like this. FeO, okay, loses oxygen. Okay, alright, to form Fe. And there you go, we're done. Right? Okay, let's move on to another example. Alright, okay, so since this is an example, right, okay, this will most likely stay in the worksheet. Let's move to the second one. Okay, as you can see here, alright, okay, this is another equation. Okay, let's analyze this equation a little bit. Alright, okay, now we're going to look for which reactant that is oxidized. Okay, now we'll start with the leftmost, okay, which is basically HCl. HCl on the left side, okay, of the reaction is a reactant. But, okay, going on the other side, okay, it becomes a Cl. Yes. All right. So from a HCl to a Cl2, what does it mean? Well, it simply means that HCl has actually loses its hydrogen to form Cl2. Okay, loses hydrogen. Now, losing hydrogen is oxidation. Yes. So therefore, I've identified that my substance that is oxidized is HCl. Okay. All right. Okay, sorry. Okay, and with that said, okay, my reason is because HCl, okay, all right, it loses hydrogen, okay, to form Cl. Now, here's the thing. You want a subscript, okay, because some formula requires you to write that subscript. Okay, now to do a subscript, you can actually press a button here or something like that. Let me see if I still remember this or not. Oh, sorry. I think is oh no. Um, okay. Let's see if I could do fonts. No. Okay, it just doesn't quite sink into me. Okay, never mind. We'll just do a Cl2 first. Alright, okay, and to continue from here, okay, so which substance is reduced? Okay, very simple. So since we already found the substance that is being oxidized, then the opposite, okay, which is the other reactant, will undergo reduction, which is in this case F2. F2 is actually reduced, right? And my explanation, okay, to this is that, okay, the F2, okay, gains hydrogen, right, to form HF. Now, one thing to take note, okay, you notice that I do not include the balance equation inside. Okay, there's no need to. Focus on the formula will do. Alright, okay, and the gain of hydrogen has shown that it was initially F, then it becomes a HF. Now, that H added to the formula tells you that it has gained hydrogen. Yes, okay, so we're just looking for facts like this, and these are some quick demonstration to how I work this out. So hopefully this help you with your assignment. Complete the rest of the question on this worksheet, and yep, okay, I'll see you handing in turning in this assignment. All right, okay, at the end of the lesson. All right, thank you very much. Hi everyone. Okay, before we end off the video, I'd like to catch up on one of the things I was struggling to do just now. Alright, okay, that is to create a subscript for the chemical formula Cl2. Right, as you see previously, my Cl2 was like this, okay, and I couldn't find the key to cause that 2 to become a subscript. Okay, so I actually just kind of figured out after I test it out. So just like to share with everyone, so if you're typing this answer out, it should be quite convenient. Now, I'm not so sure about those people using tablet, okay, but if you couldn't do it, okay, I'm just still fine with you just writing that number 2, that would be fine with me. Okay, but if you want to make your answer something very similar to a chemical formula, now this is what you could try. And if you're using a keyboard, okay, that would be very helpful. So on this Google Doc, okay, what you really have to do is just simply press 2 buttons together. I'm going to write down the 2 button. Okay, the 2 button is Control, alright, okay, which is the corner left button, control, and you press it together with another button that looks like this. Okay, sorry, it looks like this. It was a button that has both comma and an arrow backwards, okay, which is greater than arrow. Okay, so if you press these two together, okay, what happens is that you create a subscript for a number. Alright, okay, so control and the greater than arrow, okay, or also known as the comma arrow. Now, it in a normal keyboard setting is actually right next to the letter M. So let me show you now. Okay, so I'm going to write CL2. So what I do is that I press control with the arrow and immediately notice that the size of my cursor, or rather immediately shrink to half. And now I press 2. Now there you go, it looks as a subscript. Now if you do it again, control arrow, right? Okay, you go back to the normal font size. Okay, and yeah, that's it. Basically, it's so simple. So let me do that again. So this is F2. I press control arrow, okay, which is less than arrow, and I press 2. Now this fluorine looks more like the F2 that we are familiar with in formula than anything else. And if I were to press back F2, control arrow, right? Yeah, my font goes back again. Okay, right. So last try. Okay, one more time. Okay, control less than greater than arrow. There you go, it shrinks down. There you go, you press the 2 and you press it again to revert back to its normal size. Now this is one of the ways, okay, that can make your answer very much similar to a chemical formula. And I hope this helps. Okay, with that said, that will be the end of my lesson. Complete the homework assignment, turn in the assignment. Please click a like to this video, okay, because it's going to help me know and monitor how many people are actually watching this video. Alright, how many people actually stay throughout and watch this video, and that's going to be very helpful, okay? I need this information to know if you're with me. Right, that's it. Thank you so much, and yep, see you again.